Before actually I go to my presentation, I'll give you just a little bit of overview of the institute where I work, just to give you some ideas. So AIFS was developed back in 80s, at the very beginning of 80s, and it was a sort of, it was created in order to evaluate family law reform in Australia. And all the studies and everything what was done within AIFS, it was about family law. As time passed, the institute grew dramatically, and it didn't actually grow much in terms of the size of the institute. We still got no more than 70 people, and 40% of them are corporate people. Only 35, 40 people are actually researchers. We've got a very large programs within the institute. We've got a huge program on longitudinal studies. We've got a huge program on policy and service systems, family law and family violence, practice evidence, engagement, Australian Gambling Research Centre, and Data Linkage and Integrating Authority. I'm not quite sure how many of you know Johan Koskinen, but he said to me that I definitely need to put a kangaroo here. So that was only for him to put a kangaroo here, but I thought just to put a kangaroo would be quite boring. So I'm not quite sure how many of you know why, for example, Australia have got on its crest kangaroo and emu, and simply because, first of all, it's a national animals, but those two animals, they actually can't go backwards. They only can go forward, and it was the way why Australia wanted to move only forward. So this is only, so who knows, Johan, you need to tell him that I did use kangaroo in my slide. Within the longitudinal studies, we actually manage currently four really big longitudinal studies. They're growing up in Australia. The study commenced in 2004, and it's following 10,000 families. We've got Australian Temperament Project. This study actually started in 1983, and we've started this study now. We're only partially involved, and the study is run by various universities. We've got Building a New Life in Australia, the study that started 5 years ago, and it's about the humanitarian migrants. And this study is translated everything in 15 languages. We've also got other studies that have been in the past, and just last week we also took on board another study, longitudinal study of male health. So what I'm going to do today, I'm going to talk about the longitudinal surveys and the administrative data. And I'm not going to give you all the information about how to do the data linkage. I'm not going to give you all the information how to do the statistical analysis. I actually would give you just an overview, and this overview will be mainly from the Australian even context, what challenges we've got in linking the data from different admin data sets to the survey. And I think this is the question that I hope I will cover a little bit, maybe not fully answer. So my talk will be in two parts. The first one, it will be data linkage methodology, just for those who have no idea what data linkage is, just to give you an idea what it is and how it's done. And then I will use the longitudinal study of Australian children. From now on, I will be calling it LSEC, just to make it easier. And I'll show you some challenges that we've got when we're linking various data sources. So data linkage methodology, very simple. You can read the official definitions, but very simple that you've got two data sets and you bring them together. What you need to have in those data sets, you need to have some kind of overlapping fields on which basis you would be able to link them together. This is, I think, why I put this quote, because I really, really like this quote. I'm not going to read this quote, but it's basically data linkage is not a new thing. Data linkage first was mentioned by Dunn in 1946. And then it was developed, and this is how it was developed. That this graph actually was extracted from one of the Heron's publication, and it shows data linkage activities and PubMed publications, search results using words data linkage by year of publication. As you can see, there is a huge rise in 90s and then a huge rise in 21st century, and simply because it reflects the development in technology. It's nothing new, it's just now technology actually allows us to work with huge and very big data sets. And all of these, it's actually a reflection of what has been done with linkage of admin to admin data sets. So if you think about the linkages, there are two directions mainly. First direction is when you've got various administrative data sets. So for example, education, welfare, health, hospitals, and you link them together. And it's usually on population level, usually doesn't require consent, especially if it's a health research. For the healthcare research, the consent can be waived. And as I said, it's usually on population level. Really, really good example, especially within the UK context, it's work by Administrative Data Research Network. UK, Wales, Scotland. Scotland has done an amazing thing. In Scotland, for example, they've got a longitudinal study of Scottish people. I'm not quite sure exactly how it's called, but what they've done, they've extracted, I think, 5 or 10% of the Scottish population, and they're linking all various admin data set, and they follow those people longitudinally. The thing what I'm going to talk about today, it's different. It's not about linking admin dataset to admin datasets. It's about linking the established survey to administrative data. And for these, the biggest trick for these actually linkages is the consent from the individuals are required. It's one, at least in Australia, it's one of the conditions. So for example, in your context, Avon longitudinal study of parents and children is the longitudinal study that has a lot of data linkages going on. So this is now, it's not going to be complex. This is now about the data linkage and what is actually important within the data linkage. The main thing in data linkage is that you've got data custodians. So you've got data set 1, data set 2, and you are not allowed to link these together. So basically, the main principle in any data linkage, it's a separation principle. Those people who do have identifiable data, so when I talk about the identifiable data, it means that I can identify who participated in the study. So whether it will be residential location, names, surnames, like anything. So and usually it's sent to the third party to undertake this linkage. And even within the third party, it's supposed to be a separation principle. So they usually work within the two framework. The first domain, not framework, domain, it's a linkage and validation. So basically data custodians send all linkage key fields. Linkage key fields, it's identifiable data identifiers to the linkage and validation, and they send some kind of record ID that you can link those files back to the contents, so to the variables, any data that you collect. And then those people who undertake the linkage and validation of their linkage, then they create a linkage key. They delete all the identifiable data and they send it to the data integration domain. And within the data integration domain, those linkage keys, those linkage keys, they're now in the dataset 1 and dataset 2, and they're identical. And you just link using this data linkage key. And then if the data is really secure, then all the researchers, they actually don't have the access on their computers or anything, they're going to the secure environment. Or they're basically going to the secure environment, and everything what they do, it's actually in the iCloud, and they are not allowed to take any results of their work without checks by the third party to ensure that actually nothing has been released to the public. There are different linkage methodologies. I'm not going to go through all of them. What I would like to mention, two methodologies that are mainly used when we talk about the survey data and when we talk about the admin data. It's a deterministic and probabilistic linkage. When we talk about the deterministic linkage, it's a very simple linkage. It's basically you decide that I will be linking my data sets on 4 main variables. It will be age, it will be date of birth, it will be name, surname, and it will be gender. And those 4 fields need to be identical in both data sets. And only if they are the same, the match is actually created. This is a really it's a good methodology when you know the quality of the data is great and amazing, because it's a greater certainty in found links. But if there is, for example, you are missing or you're using nickname instead of Jennifer, it's Jen, that's it, the match is not there, and there is a greater number of missed links within this methodology. I've got a lot of slides about the probabilistic linkage. I'll try to go very quickly through them. So what is probabilistic linkage? Also exactly the same, you identify the field that you would like to use for matching, but you allow it's basically fuzzy logic. So you allow some discrepancy between these. You allow that you can have Jen, you can have Jennifer, and you will create some weights to identify this link. So, and basically what you do when you do this logic, you assign the probability that identifies what is the probability that those records, 2 records from dataset A and dataset B, belong to the same person, and what is the probability that they belong to different person. So, and this is basically the whole procedure. You've got 2 datasets, you put them to this process, and this is what you've got at the end. Just very, very briefly, I'll give you some explanation what each process is. So standardization, it's about when you need to measure apples with apples. You don't want to measure apples with oranges. So for example, if you take dataset A, in the dataset A, your gender is recorded as MF, and in another dataset, it's recorded as 1, 0, or female and male, that's it, the logic is not going to work. So basically, you need to go through 2 datasets, and you need to make sure that actually you're comparing apple with apple. So again, when you look here, you need to make sure and you make some assumptions what you're going to do with Kathy, Catherine, and all these definitions, how you're going to do it. And usually you assign various weights and probabilities to that. So then you go to the blocking and searching. And usually probabilistic matching is used very, very widely in when you link admin to admin data. And why you do the blocking? If you just imagine that you've got 4 million, if you're trying to match 2 data sets, in one data set you've got 800,000 observation and another 4 million, and you've got even just 4 variables to match, and if you go through all this loop, this is a very computationally intensive process. You don't want to do it. You actually want to have an efficient search. So you don't want, if you know that this person was born in 1995, you don't want to look through all the people who were born, for example, earlier than 1995. So you identify your blocking, and your blocking, it's a set of variables that you think that they are core. So for example, you can say that my core variables are day, month, and year of birth, and within 2 data sets, you identify those individuals who were born on this particular day, in this particular month, in this particular year, and you compare them on other variables that are important for your linkage. So for example, it will be name, it will be surname, it will be residential location, and other things. What it does, it just simply making your process much quicker and more efficient, and you can create various blockings even when you do one data linkage. So you don't necessarily need to use this one. You can do various blockings and you can compare the results. So then you go to the comparison, and this is where the comparison actually, you use the statistic, and it's actually statistical methodology behind this, which I'm not going to go into details, but basically what you do, you compare 2 records and you assign weights. You can assign either 0 or 1, or you can assign various weights, because, for example, this is how you can assign weight. If within your names you've got just 1 letter different, you can assign this weight. If it's a first letter, it will be 1 weight. If it's a second letter, it will be different weight. And then you use all of these weights to actually understand the partial agreement on various fields. So, and then you assign the probability. So for example, if we look at sex, you've got, if it's the same person, the probability that is the same. If we say that yes, in this data set it's a girl and in this data set it's a girl, so the probability that they are correct is really, really high. But it's also a very high probability that it can be mismatched, because probability of being a male and female, and so basically having a mistake in one of the data sets. So why actually, just also to say, various data sets, admin data set, they've got different quality. And it's quite possible that in one data set, something what you've got is actually incorrect. And you need to make a decision on what you're doing. So, but if you take date of birth, if you've got 2 people who are actually have exactly the same date of birth, the likelihood that it's the same person is much higher. So the probability that this person is different is much lower on this particular variable than when you talk about sex. And you assign particular weights. And again, this is, the linkage process is quite, and why I actually wanted to go in a little bit more details, you will understand later when I provide you an example. But what I wanted to show that actually this is quite subjective procedure. So you put your assumptions and you test your assumptions, and your assumptions actually drives your results, because you are the one who are deciding what is the threshold for the probability to decide that this is the same people or this is a different people. And then you identify bad links and good links, and then you use again decision model to decide. So this is basically, you've got real matches and you've got links that were identified by you. And this is the proportion of the proportion correct links basically. Then you've got non-links and non-matches. When I refer to the non-matches, it's a true non-matches. So it's a true different people. Non-links, it's what I identified across 2 data sets as they are different. But when we look here, this one. This is actually possible links. We don't know whether, we can't be certain because our probability actually doesn't allow us, it doesn't fit our threshold. And with those ones, what we're doing, we're actually doing clerical review. Clerical review is when you actually checking it manually. You're manually going through two different data sets and you try to write some kind of program to identify the links to help you. But basically, this is the gray area where you do the clerical review. I'm not good. And this is, you've got some quality measures that you can use to identify. And basically, if you just do the cross step, as I mentioned before, you've got 4 different possibilities. You've got true links, you've got true non-links, and you've got false links that actually you say that, yes, this is a link, but actually those people are different in reality, or you say that there is no link between those two people and those people are matches. And you can calculate the quality measures. So basically, what I wanted to show you this, I wanted to show the data linkage, especially probabilistic data linkage. It's a very subjective procedure, even it's a very statistical procedure. But when the data linkage is done, what is really, really important, which doesn't actually happen on regular basis, and it's quite a rare exercise, this third party who actually provide you the data linkage, they need to provide you with a list of all identifiers they've used, what variables they used, what logic they used, what kind of they need to describe the linkage process that they've done, what thresholds and probabilities they've used. Because when you do the analysis, you need to incorporate this in all your analysis. And then you can also evaluate the quality of the linkage process. So that was very quickly, very, very rough overview of what is data linkage. I'm pretty sure that within your school, you've got Natalie, who knows a lot of this stuff, and Mark Elliott. So because I will be gone, I won't be able to ask any questions after an hour, but they will. The next one, I wanted to give you an example about lessons to be learned from the Australian context. And as I said, I would be giving you an example of longitudinal study of Australian children. As far as I know, this is one of the data sets across the world they've done such an intensive linkage. For example, if we consider Understanding Society, this is an amazing and huge data set, UK data set that is run by Essex University. They do a lot of linkages, but they haven't done a lot of linkages. So they're either in the process, or they're proposing them, or they're considering them. The same as LSPAC, the one that I mentioned before. This study has actually implemented a lot of linkages, and a lot of research has been done with linked data. Just to give you a feel, what is the LSEC? As I said, it's a first nationally representative birth cohort study. 10,000 families were recruited in 2004, and then we follow up families every 2 years. We've got 2 different cohorts. One cohort, it's a B cohort, baby cohort. They were born between March 2003 to 2004, and K cohort, they were in the kindergarten when they were recruited, and they were around 4 years old. So this is just to show you the sequential design. What we get from this study, we actually collect information from various respondents. We collect information from parents, we collect information from both parents, we collect information if parents actually separated, we follow this parent living elsewhere, we go to teachers, we go to carers. For B cohort, we've got biobanks. So 2 years ago, everyone who agreed, and it was around 70% of B cohort children, actually the whole health check was undertaken. It was around 4 or 5 hours health assessment for them. And this is an ongoing study. So this study is, as far as I know, is never going to stop, and we are hoping to follow these people as long as we can. Not that they're very happy about that. There are different type of linkages what we do with LSEC. We've got individual linkages when we link data at the individual level. So for example, if we've got national assessment of their academic performance, and this is available at the individual level, we link at the individual level. We've got linkages at the organizational level. So for example, we link quality measures of child care kids attended. We link various academic performance of school the child goes, and this, for example, schools data set has everything. It has a ratio of students and teachers. It has what is the proportion of boys and girls, all the financial data for every single school child attends, and also it has the socioeconomic index of this school. We also, for every single participant within our sample, their residential location is geocoded. And we do geographic linkages, but geographic linkages is slightly different from other linkages because, first of all, we link a lot of census data, we link a lot of region data and everything. Currently, what we're trying to do, we're trying to link environmental data and various parks and fast food stores and all of this. But usually for the geographical linkage, what we do, researchers would send us a request and say we would like to have this data to be linked. They provide us with the data and we link this data. So the other thing, probably before I go into details, what I would like to mention that Australia is a huge country, and even so it's a huge country, people usually just live in the main cities and just along the coast. Australia is federation, and because it's federation, it means that we've got two different levels of data. We've got Commonwealth data and we've got state-based data. So what it means that Commonwealth data is when the data collection across the whole Australia. So and the data collection is identical. For example, Medicare. Medicare, it's a health, not health. Medicare, it's census. It will be easier for me to explain census. So census will be identical across all states and territories. When we go to the state-based data or educational assessment, it's also national, it's Commonwealth data. State-based data is different. So every state and territory, they collect their own data. They not necessarily share with the Commonwealth, and they not necessarily actually talk to each other in terms of the definitions and in terms of how the data collection is happening. And I'll give a few examples later on. But I just think that it would be quite important to keep it in mind when I give this presentation. So this is the list of all data linkages that has been done currently. And the one that I actually highlighted in a different color, it's the one that those two we are developing because we've got quite a lot of challenges to undertake this linkage. Majority of the linkages that are presented here, it's Commonwealth data, and those ones that are highlighted, it's a state-based data linkage. That's why it's much more difficult to actually undertake this linkage. And what I would like to focus more and in more details is steps that were involved in data linkage that we undertake. And I think I was thinking about it because we've never had actually a formal steps that we go through. So when I was preparing this presentation, I went through in my mind what we actually do. And I would say that we've got 5 main steps. The first one is identification of potential link data. The second one is developing the consent, because without consent, we are not able to link. The linkage itself and what kind of problems we've got with the linkage. Then preparation and confidentialization of the data, and then release this data to the public. Because the other thing what I forgot to mention, that LSEC is fully public data set. So everyone across the whole world can get access to this data. They just need to sign the deed of license. And we've got 2 different releases. We've got a general release where everyone can get access, and we've got in confidence data file, and it's not available outside Australia. And for those who would like to get access to this within Australia, they need to provide like much stronger justification why they would need to have more sensitive information. So in terms of identification of data set, I think things to consider, we don't want, and I think this is a big issue now, because people get an opportunity to link the data, and they're trying to link everything to everything without actually thinking why they're doing it. It's quite an expensive exercise. It takes a lot of time. And what we're trying to do, we're trying to make sure that actually linkage is cost effective. And when I talk about cost effective, I just give you a very quick example. When kids within LSEC, they finish school, when you sit exams, you just need to choose any 5 subjects for your final exams. And actually, this data is recorded administratively at the state level, state-based level. And the same as scores as a final score for school. But for us to go and actually access this data from every single state and territory would require a lot of time, it would require a lot of money, and we would need to still go to the individuals, spend 2 minutes, and 2 minutes for us, it's a huge amount of time in a house to explain the consent form, and they still need to sign the consent form that this is what we're going to do. What we can do, we can just have 2 questions in the questionnaire and say, just list us what subjects you undertook when you were in the last year of your school and what score you would have. And people would know almost by heart what score they would have. So this is what I'm talking about, the cost-effective, timely. Some of the data linkages that I've presented to you, they were definitely not timely. So in order to link educational data, it took us 5 years to sign all the agreements with all the government departments to make sure that this data linkage can happen. That they're not intrusive. So when I talk about non-intrusive, we talk now a lot about linking social media data. And I'm probably, even so, my background in social networks and development social statistical models of social networks, and this is my passion, I'm quite reluctant to actually ask individuals to please give me access to all your social media account and I'm going to link them and do, because first of all, at this point in time, I'm not quite sure how much information I'm going to get from this, how it's going to be used for the research purposes. This information cannot be just linked. This information needs to be actually cleaned up, and it needs to be provided to data users and explain how and what questions can be answered. So I'm not quite sure how it can be. And plus, technology changes so quickly. By the time we get the consent for them to, for example, to link to their Twitter or Facebook account, I have no idea what other social media would come into play, and maybe it will be not relevant anymore. And now it's becoming actually very, very expensive to link to the social media, because before it used to be free, you can just get to those data owners. And also what it can affect, can affect respondent engagement for future wave. If I come to the respondents and I say, I would like you to provide consent for me to link to all your health data, welfare data, education data, Medicare, everything, and now I would like to have access to your social media, I'm not quite sure that it's not going to affect the respondents' engagement in future. And as I said, fit for purpose. We try not to link data sets if we can't see how this data set is going to be used, or whether this data set is going to add any value to what already has been collected, because our interview is almost 2 hours in a home, and 2 hours of 2 or 3 people participating concurrently. So we always try to make sure that whatever we link, it has particular purpose. So, and now I will talk about consent rates. So as you can see, the consent rates are really, really, really high for us. But the consent rate that I'm actually showing you, they are consent rates from the eligible sample or respondent sample. So if we talk about wave 6 consent, and we've got 92% of children who actually consented, it doesn't mean from the original sample that we recruited in 2004, this is the proportion of children who actually agreed. It's from those kids who were still available to participate or who agreed to participate in this particular wave. What are the main challenges that when we talk about the consent? And I think that consent should be informed. And when I talk about the consent should be informed, it's a very interesting thing, because our Department of Human Services, they've got a really long consent, which a lot of technicalities and everything. And what they do, a respondent needs to read this consent, they need to understand, they need to sign, and it should be a manual paper. Then this paper needs to be scanned, sent to the department, and every single consent will be checked manually. So if we've got, for example, if we've got a full sample of 10,000 multiplied by 3, because within each household we've got around 3 people, so it's 30,000 forms that needs to be checked manually by the department. And for building a new life in Australia, every single form needs to be translated in 15 languages. So, and we are trying to, and there is no way that we can actually try and say that let's do consent via online. So they just stick. It's not possible, it's not allowed. The consent, it should be a signature in presence of the witness, and it should be on paper. For how long is consent valid? This is another thing. So when you develop your consent, you need to be very, very clear for how long this consent is valid. Because if you miss this, that's it. All these data custodians that won't let you to link anything prior or after the day of the consent was signed. And if participants, because it's a longitudinal study, if participants, for example, decide to withdraw from the study, we still would like to link their admin data because it will give us more information, it will give us richer data sets. So we need to be quite clear in the consent that this is going to be the case, or they need to officially or explicitly withdraw from the linkages. And if it's not there, that's it, we are not allowed to do it. State-based consent, again, consent requirements can be quite different across states. Consent can be different from various respondents. So again, as soon as children are becoming 16 years old, exactly the same consent that we ask of parents on their behalf, we would need to go and ask them. Challenges that we've got with linkage. I think this is the first one. It's because majority of our linkages are deterministic linkage rather than probabilistic linkage, we are losing quite a lot of potential links. And because currently it's, the environment within Australia is changing, but especially when we link Commonwealth data can be linked only by 3 organizations in Australia. And especially if you, and we are one of them, but we still can't get access to this data, because to get access to this data, you need to pay thousands and hundreds of dollars. So basically those departments are doing the linkage themselves, but they are not doing the linkage as data linkage. They're just extracting the data based on these linkages. Then it's also quality of administrative data. We don't know the quality of administrative data. Issues with cross-jurisdictional and also introduction of new source of error. Then you bring the new data sets. Very, very quickly about quality of admin data. Definitions within admin data can change every year. So you need to make sure that actually when you provide the data sets to data users, you make sure that you harmonize all these different variables across different time. And also that you need to remember that admin data is collected for a particular purpose. And if we think, for example, about the financial data that would be linked expenditure, and we link credit card details, it doesn't mean that some people just don't have credit card details. And if we can't see the expenditure for these people, it doesn't mean that they don't spend their money. It's just they're using different methods. I'm not going to go to these details, just to show how differences actually across time are huge. Very quickly about the challenges and cross-jurisdictional data. People move from one state to another, and it's a really, really common in Australia. Moreover, people who are living on the border, they don't necessarily use services of the state that they are living in. They're using services across the border. So when you do linkage for the longitudinal data sets, you can't just go state by state. You actually need to try to get linkage across every single state for every single individual in your study, regardless which state this person is residing. Also, data access is very different. Consent, as I said, is very different across state. Comparability. Comparability can be a huge, huge issue. So, for example, just to give you, up to 2016, non-attendance was measured very differently across every single state. Not only across every single state, it was measured differently across different schools, if it's a Catholic school, if it's a government school, and if it's a public school. So the definition and the framework, so some had partial attendance. So if you were absent for half a day, you will be considered as fully absent. Some you would use partial and fully. So this is just to give you an idea. But what you are doing, you're actually linking back to at least 2004. And you can't just release it to the people, to data users. You need to do some kind of harmonization. This is a really interesting example. This is the health data, because health data, like emergencies, admission to the hospitals, is collected by state and territories. And for example, the way how they record in emergencies, for example, if you look at the death on arrival for Western Australia and South Australia, the one that are actually highlighted in red, death on arrival in those states, it's not recorded in the emergency department. They're actually dismissed. So if you look, it doesn't mean that no one died there. So people did die there, but because it's not recorded, it's not there. And the other one, which is, I think, one of the most important things when you do the analysis, further analysis with your data, that you should always remember that there is an additional source of error when you bring admin data. So think about any longitudinal study. You've got a sample frame from which you actually probabilistically, you use a probabilistic approach and framework, and you create your own sample. Within this sample, you send all the invitations, and you've got respondents and non-respondents. And then, and actually those respondents and non-respondents, they keep changing every single wave. as you go through the life course of the study. Then you ask them about the consent to link to a particular data set. Some provide consent, some don't provide the consent. Then for those who consented, you've got whether they've linked the data, and we were not able to link the data. And among those who linked, actually, for whom data was linked, you've got correctly linked and incorrectly linked. And it's all at statistical actually error in your analysis that needs to be accounted. Because when you've got your sample and your sample or respondents, and your respondents drawn from the sample and sample is drawn from your population, you generate weights. You generate weights to actually account for these biases. It's quite hard to generate weights when you go through all this process, especially for the longitudinal data. But you need to account it in your statistical analysis, not to have a... this is a very interesting example that I will show you how important to actually understand what you are linking. I'm referring to the NAPLAN. This is the academic performance of children. This is a yearly test that is done across whole Australia. It's done on exactly the same day. And it's in years 3, 5, 7, and 9. They're testing numeracy, reading, writing, grammar, and punctuation and spelling. All the scores are standardized, so you can actually, within this admin data set, you can compare the progression of each individual. And as I said, it's every year. So we've asked for consent. The consent rate was really, really high. At the time when we asked, 95% actually provided consent, around 5% didn't provide, not necessarily that they refused. They probably, for example, filled form incorrectly. As soon as they filled form incorrectly, we can't consider their consent. But if we go back, this table is from the wave 1 sample, so the sample that we've recruited. For around 15% of individuals, we don't have NAPLAN data. And then we look at the linkage rates. That was a really, really good linkage because admin data set was really good. Obviously, in longitudinal data set, you've got really good data where because you go and interview participants every year. So, but still, for 16% of people, we didn't have any NAPLAN data. And when you just have a look how different actually those who don't have any NAPLAN data from the ones who do have the NAPLAN data, you can see that those who've got a low education are likely, those parents who got low education are likely not to have their child's educational data linked to their child records. Those parents whose, for example, mother doesn't work, those families are less likely to have their NAPLAN data linked. Those who are from language background other than English are less likely to have their data linked. And PPVT, it's an assessment of language skills of kids. And actually, if you see that as soon as the language skills are pouring, so the lower the score, the higher the probability that parents won't agree to the linkage. And basically what you're seeing, everyone who you would like to capture, because this is this marginal group that you would like to understand, for them, actually, you are missing all these data sets. But on top of this, there is a difference within Australia. So every single state and territory, they've got different intake in school. So some states got multiple intakes in school. And some parents can decide that I don't want to send my child in school earlier because I think my child is not ready. And the parent can send the child later. Some parents can think that, yes, my child is not yet 5 years old, but I think my child is very smart and ready. I'm going to send the child earlier on. So within, so just quickly do this. So basically, it just shows how different intakes actually affect where the child will be at the time of the enrollment to school. So, and within, because LSEC is a cohort, birth cohort, rather than year level cohort, within our birth cohort, kids who attend the same year level can be 3 years apart. So if you can have a look here. So some who took year 5 NAPLAN test, they took it in 2009, majority took it 2010, and the rest took in 2011. And on top of it, actually, NAPLAN was introduced when this proportion of kids, which one? This one. This proportion of kids actually already finished year 3. So when the NAPLAN was introduced, they were in year 4, and they've never, 25% of kids within our cohort never set year 3 test. So, and this is, if you look, this is the distribution of, age distribution of LSEC children, and this is when they took, this is the age distribution, and this is how, their age when they were in year 5 in different calendar years. So basically, we've got censored data for year levels. And on top of this, we go and we collect the data at a particular point in time. So if you want to do the longitudinal analysis, which allows you to investigate causal effect, you can't use wave 4 data, for example, to understand year 5 NAPLAN results. So the only wave 4 data you can use only for those kids, because those kids set their NAPLAN test before we went into the field and interviewed them. So there is a lot of consideration. So we've written the whole technical paper, what you need to do and how you actually need to combine your data if you want to do cross-sectional or longitudinal analysis. And to add to this picture that what we've collected in NAPLAN, because there is an attrition. As people actually go through the life course of the study, there is an attrition, and usually those who stop participate are those families who are from low-income families, English, language other than English. And even so, when we develop weights to account for our attrition, those weights don't account for the differences within the academic achievements. So there can be huge differences on top of that are not accounted. I've actually mentioned that, but I'm not going to go into details. So and just to sort of summarize, there needs to be a very big preparation of the data sets. When you've got more data and you try to increase and enhance your data set with various admin data sets, all the individuals within your data set, they potentially become more identifiable. And this is the first thing that you would like to protect when you link different data sets. So you actually, what you do when you do your linkage, you're trying to understand and you're trying to bring different variables together to see whether individuals can be identified or not. And what you do, you apply various rules of confidentialization, which in turn actually might reduce the statistical usefulness of the whole exercise. And governance, when I talk about the governance, what we've noticed, so in wave 1, we've linked a lot of Medicare data. It's immunization records, it's when they go in the pharmacy and buy something, it's all recorded what things they bought and everything. So we had all these data sitting for probably 6 years. But until we actually prepared this data, written technical papers and explained to data users how this data can be used, no one used this data. No one used this data at all. So basically, researchers need to be trained and given assistance how to do the analysis with the admin data. And also, researchers need to sign for every data set that they're using, they need to sign the deed of license, that they are not going to deliberately, for example, try to identify individuals. I've already mentioned that if we've got sensitive data sets, so for example, health data, biobank that we've collected for our baby cohort, this data is not going to be available to everyone. It will be available only on request, and it's quite possible that it will be only available in a secure environment. I'm not quite sure whether I have convinced you or not, but there are huge benefits in linking various admin data sets. It fills in data gaps, so it's also reduce respondent burden a lot, especially on something that can be easily obtained from admin data or something that we know for sure that individuals won't be able to remember. So for example, we did a test of immunization data. We've linked all the immunization data, but we also at wave 1, we asked them about all the immunization. And people don't remember whether their kids are fully immunized or not. So there is a clear cut when people know whether they immunize their children or not, but whether it's up to date or not up to date, it was a really huge variation. It allows better understand the existing data set. It's improved data quality and inform important issues of today. I had a few examples, but I don't think I've got time, actually, definitely don't have time to show it to you. And just to finalize, what I think data linkage is awesome and great, but it's only useful when we provide enough information on how data linkage has been done, how it can be used, and what needs to be considered. I think if you want to come